Hi everyone. This video is a continuation of the method of solving by square roots for quadratic equations. So I'd like to do two examples for you of quadratic equations that start out in standard form. So in order to solve using square roots, we need to rewrite these in vertex form, which is a times x minus h squared plus k equals 0. So you may remember that we have two equations for how to find h and k. We said that h is negative b over 2a. And then you have two options for how to find k. You can either plug this h back in for x into the equation and solve, or we also have a second formula, k equals c minus ah squared. Okay, so this is already in standard form, right? So we have a, b, and c, so we just need to figure out what h and k are. All right, so h is negative 2 over 2 times a, which is 5, and then those 2's cancel, so that's negative 1/5. And then k is c, that's negative 7, minus a, which is 5, times h squared, which is negative 1/5 squared. Okay, so that's, let's see, negative 7 minus 5, and then negative 1/5 squared, you can just square the numerator and denominator. So that would be 1/25. So we end up with 5 over 25. All right, and then that's negative 7 minus, and we can reduce that to 1/5. And then we needed a common denominator to subtract the fraction, so this would be negative 35 over 5 minus 1 over 5, which is negative 36/5. Okay, so we've got h and we've got k. All right, let me rewrite those. Okay, so h is negative 1/5 and k is negative 36/5. Okay, we already know a, that's 5, and then in parentheses x minus a negative 1/5 is plus 1/5 squared, and then plus a negative or minus 36/5 equals 0. Okay, so we are all set up now to solve by square roots. So once it's in this form, then we go through the process that you learned previously in the last video. So we want to add 36/5 to both sides, okay, and then divide by 5. All right, now I don't really like dividing fractions by 5, so instead I'm going to multiply by 1/5. All right, and that'll do the same thing. And we end up with x plus 1/5 squared equals 36 over 25. Okay, next step is to square root both sides, and right away put a plus or minus sign on the right. So we end up with x plus 1/5 is plus or minus, and then we can simplify the square root, so I might just do that right now. All right, square root of 36 is 6, and square root of 25 is 5. All right, then subtract 1/5 from both sides. And again, this gets written out front, so this would be negative 1/5 plus or minus 6/5. Now, if this had a square root in it still, we would stop here, but since we can combine fractions, then we should simplify. So let's do that. All right, so the two answers would be negative 1/5 plus 6/5, and that's 5/5 or 1. and then negative 1/5 minus 6/5, which is negative 7/5. All right, so your two answers would be 1 and negative 7/5. Again, this one has integer and fraction solutions, so you should be able to factor this as well, and that would be a nice way to double check and make sure this is correct. You could also just substitute your solutions into the original equation, see if it makes it true. Okay, here's another one. So this one, even though the numbers are large, looks like the GCF is still 1 because 41 is a prime number. Right, and 41 doesn't divide into 56, I know that. All right, so if you tried to factor this, again, this might be a situation where the numbers are fairly large and it's not really convenient to solve using factoring. So let's try our method with square roots again. So the formula for h, negative b over 2a. So here that would be negative 56 over 2 times 1/12. And that reduces to negative 1/4. All right, again, I'm going to leave this as a fraction. That's preferred at least until you get to the end of the problem. And then k, we want c minus ah squared. So that would be negative 41 minus 1/12 times negative 1/4. Okay, that's kind of an ugly number. All right, negative 41 plus, and then 1/12 divided by 4 is 28, and negative 41 plus 28 is negative 13. Okay, so rewriting this in vertex form, we have a, which is 1/12, in parentheses x minus h, minus a negative 1/4, squared, plus k, plus a negative 13, equals 0. Okay, and then solve using square roots. So first get the part that's squared by itself, so add 13 to both sides. X plus 1/4 squared equals 13, and then divide by 1/12. Alright, so we end up with the squared part equals 13 over 1/12. Okay, then square root both sides, put in the plus or minus sign, and we get x plus 1/4 equals plus or minus square root of 13 over 1/12. Then subtract 1/4, and we get x equals negative 1/4 plus or minus square root of 13, and I'm going to write this as 2 square roots now, over square root of 1/12. Okay, so the only thing left to do is just to simplify the square root, and square root of 13, that's a prime number, so that is simplified. Now we have to simplify square root of 1/12, so this should be a good review of how to do that if you don't have a calculator that does that for you. Alright, so I need to figure out what are some factors of 1/12, and I like making a factor tree for this. So this is, I know 2 goes into this. This is 2 times 56. 56 is 2 times 28. And 28, I'm going to choose 4 times 7 because 4 is a perfect square. I like those. Right? Same thing here. 2 times 2 is 4, which is a perfect square. So I'll rewrite this. Square root of 1/12 is the square root of 4 times 4 times 7. Okay, so one of those 4s is the 2 2's, and then we've got a second 4 and the 7. Alright, so one of your square root rules, you can break this up into a product of square roots. This is square root 4 times square root 4 times square root 7. The first 2 I can calculate. Square root of 4 is 2. And then these are all connected by multiplication. So then you just recombine anything that's left outside of the square root or inside, and that's 4 square root 7. Okay, so then rewriting the answer that we had from before, instead of square root 12, we're going to write that as 4 square root 7. So we've got x equals negative 1/4 plus or minus square root 13 over 4 square root 7. All right, we're still not done. Another simplifying rule, you can't leave a square root in the denominator. So you might remember we need to rationalize. And to rationalize, you multiply this by whatever that square root is that you're trying to get rid of, so square root 7, in the numerator and the denominator. And remember that this expression just equals 1, so we're not changing the answer here. Okay, so that gives negative 1/4 plus or minus. Then in the numerator we have square root of 13 times 7. Now those are both primes, so I know that even when multiplied, that square root won't simplify, so we do want to multiply that. And let's see, I think that would be 91. And then in the denominator, we'd have square root 7 times square root 7, which is square root of 49, or 7. And then times the 4 is 28. Okay, so finally we're done. Okay, I can't simplify square root 91, and I can't reduce the fraction, so we can leave it like that. Some people like to get a common denominator now and make this one big fraction, so you could also write this as, let's see, multiplying the first fraction by 7 over 7. You'd have negative 7 plus or minus square root 91, and then the whole thing would be over 28. So either of those two answers is good. Okay, that's it, and thank you for watching.